right, so the other day we left off doing this exercise at the very end of class. So we're going to move into exercise number 3 here. And this is one where I actually want you guys to work on it together in class and see if you can figure out how to do it. And I want to come around and check on you and see how you're doing, because this gives me a good feel of who is understanding joins and who isn't. So I'm actually going to pause the video for a minute. So let's take a look at this and break it down piece by piece. So for just a moment, let's hands up and eyes up for just a second and take a look at how we think through this, and then we can maybe catch up and type in a minute. But I want to make sure we understand what's going on here. So for every item on order, so that means every order that's occurred, I want the order number. So where does the order number come from?
It can come from the order or the item.
All right, so we have order num, right? We're going to have a select here, obviously. So order num, and it can either be the orders table or the order line table, right? All right, so let's figure out which table we want in a minute. Next up, we have the item number. Where does that come from? Item or? Order line again.
Order line, sorry.
Okay, yeah. So order line. So item number can come from order line or the item table. Order num can also come from order line or some other table. So that's two fields from the same table, potentially. How about description? There, we have no choice on that one. That is from the item table. Now, do I have to qualify
No.
item?
Not on that one.
I don't have to qualify. Why?
Because it's only belongs in the item.
Yeah, there's no other table in the TAL database that has a field called description. I decided to qualify just so we know where it's coming from, but we don't need to. Okay, number of units ordered. Where does that come from? Only the order line, right? So this order line table seems to be kind of a big deal here. Num, is it num ordered? Yeah. All right, number of units ordered. How about quoted price? Where does that come from? Also order line, yeah. It's the only place you can get that. So quoted price and unit price. Where does that come from? From item, right? The item table. So item dot, I think it's just called price, yeah. Okay, so from something. We'll deal with that in a minute. So the question is, which table or tables are we going to use for those two fields? We're using the item and the order line for everything else. So which tables should we use here?
Order line would be good.
Yeah, order line, because if I don't use order line for both of these, so let's leave, yeah, so if I used orders here, well, now I've got 3 tables instead of just 2. So why not keep it simple and just stick with 2, right? So I got 2 tables that I have to pull data from. So the first step whenever you get an assignment like this, and by assignment I mean, yeah, assignments from me in class, but I also mean from your supervisor at work or from whoever tells you to write your queries, right? Whenever you're told to write something, you'll get a thing like this. For every order we have, I want the order number, the item number, the description of the product, how many were ordered, what the quoted price was, and what the actual price is supposed to be. And so I just listed off the fields, that's all. Turns out half of them are from one table, half are from another table. So when I do my from, I need to select from order line, and I need to select from item. That's it, right? What is the condition, though, that I'm going to be doing the select? Yeah, it's where order, and I got a typo right here, I just noticed.
So are you
What I do,
want it that way, or you don't?
stand by for just a second. So order line dot item num equals item dot item num, right? That will give us what we're looking for. So what was your question?
Wouldn't you rather have it join? Because like you said, there's no other.
Personal preference, yeah.
Okay.
It's whatever you prefer. We're going to cover both, so that's why I'm doing this one first. But yeah, I do prefer the join syntax, but I want to make sure we know how to do both, because you got to know both, yeah. So this will get us what we're looking for here. And so use TAL and run that query, and there we have exactly what we were told. The order number and the item number, and the description of the product purchase, how many were ordered, what the quoted price was versus the official price. So it looks like the first one there, the wooden blocks, they knocked off $3 or $3.50 per item, right? Or is that 2.5? Whatever. Do the math. 3.5, I think. Yeah. Okay. But so this can tell us some good information as a company owner or as a department head or something like that. The accounting school that I worked for, I was the department head of the IT department. It was called the Internet department. And I actually it was like it was my own business. I had to run it, like I had to look at all the financial statements and the profit and loss, and I had to run my department like it was my own business. And so I had to ask questions like this all the time, having to do with internet sales and expenses and salaries and all this kind of stuff, and I had to constantly ask these kinds of questions. Luckily, I'm a database guy, so I can just dig in and find the data, okay? But this is a valid thing that you might get asked. All right, so next up, let's do this exact same query using the join syntax, right? Well, we don't need to change the select clause, that's identical. We're gonna go from order line, join item, and then on, just what we had before, item.itemNum is equal to order line, or whatever that was, .itemNum. My fingers had a seizure there. All right, that's exactly the same query. We get the same results. Feel good about that one? Pretty simple, straightforward syntax.
What do you think is the best practice in this?
There isn't one. Yeah, you have to know them both. Yeah. So the question was, what's the best practice, comma syntax or join syntax? And the answer is, there isn't one. If you're going to do outer joins, which we will learn how to do that, and they're very common, you have to know the join syntax. You have to know it for that. If you're looking at other people's code and you prefer join syntax, I guarantee you're going to run into comma syntax. You'll see both in the industry. And if it's just a quick query, I might just do the comma syntax. It just depends on what I'm doing. Generally, I favor the join syntax, so I just prefer that. All right, next one. Find the description of each item included in the order number 51623. So I saw a bunch of people as I was walking around the room, they were pulling up that PDF that has a list of all the tables in it and everything, which is fine. You can totally use that. It's a good reference. But why do that when you've got the database right here? You can just look, right? You just query the table and look. And so let's kind of use that. We want to know what the description of each item included in the order number 51623. So let's take a look at the orders. Select star from orders, where order none is equal to 51623. Not order num, order line. Why does order num not do me any good? Or why does orders not do me any good? Yeah, it doesn't tell me the product that was purchased. I need to see the product that was purchased. So now this will tell me there were 3 things purchased on order num 51623. They were DR67, FH24, and KD34, whatever those are. Now this is the kind of question you might have gotten asked in week 1, where you'd have to go look in the PDFs and see what the answer was, right? Well, now we can do a join and figure all this out. Or in our case, we're going to do a subquery, all right? So this chapter, which is chapter 5, is all about multiple table select statements. Up until now, we've only learned how to select from one table. Now we're doing multiple tables. Well, there are multiple ways to do multiple table selects, right? We can use the join syntax, we can use the comma syntax, we can use subqueries, right? So we're going to do a subquery here. What I'm looking for, I need to know the description of those 3 things. Isn't that all I'm asking? Just what's the description of those 3 things? Okay. Now this can be done with a join, but we're going to go with a subquery. So I need to know this. Let's go to my text editor here and do select description from item where item num is equal to, or sorry, is in. I wouldn't type this, by the way. This is going to be bad. Select description from item where item num is in DR67, FH24, and KD34. Isn't that what I'm asking? Isn't that ultimately what the query is asking me to do with the question right here? Isn't that what it's asking? Find the description of each item included in order number 51623. Do you agree that that will actually give it to me? Yeah, it will, right? What's the problem with that, though? Let's run it and see. It will work, no problem. But why is that bad?
Waste time.
You had to take 2 steps because you had to go look up what they were.
I had to go look up and manually type them in. It's maybe a time waster, right? And what if the order gets updated and they add a 4th thing? This query is no longer valid, right? Now, the odds of an order getting updated is pretty slim, but other things that you might be searching for in other tables, yeah, there'll be cases where one day it's only these 3 things, the next day it'll be 10 things, and the next day it'll be 20 things, and to have to go in there and manually look up every one of them is ridiculous. So we've already seen a subquery before, right? So what I want to know is, instead of this, let's break this down a little bit. Instead of saying where item num is in there, what I'm really asking for is this. Select item num from order line where order num is 51623. When I do that, that gives me those 3 numbers. So instead of explicitly asking for those 3 numbers right here, I'm just saying run this query which will return those 3 numbers and then give me the description from the item table where the item number is in the list of those 3 numbers. Does that make sense? So the inner query runs first. Do you understand that? Run it, and we get that same list right there, okay? So just had a question of this right here in my where clause. What goes in here will be that. It will match this. Because I'm saying where this item number matches these item numbers. Now, I could put something else where that item number matches these order numbers. I'll just never have a hit, right? I'll never have a match, but it doesn't have to be the same as far as syntax goes. But if you actually want to get a match, then yeah, you're looking for the same. And now you wanted to see the code. Was there a question?
No.
No? You,
Just me trying to.
okay. Okay. That's fine. Okay. All right. Let's make sure we understand, though. Looking at the code, do we understand what's happening here? Thing number 1, this query runs, and it returns a list of 3 IDs, item numbers. And so it's essentially the same thing as just these guys right here just being listed right there. It literally replaces that query with those 3 numbers. And then I'm asking the question, all right, give me the description from the item table where the item num is in that list right there. That's it. Okay, that's a subquery. Okay, questions about that? Yeah.
So, another table.
Well, yeah, like if it returned a whole table, yeah, very good point. So in other words, if I did this, right,
Yeah.
that would not work because as far as syntax goes, it's okay. But the item number, this actually might give an error, but forgetting the error possibility, we'll test that in a minute. Either way, item number's trying to match 9 fields or whatever are in the table, and that it won't work. That'll probably give me some sort of error. Let's find out. Yeah. So, and it even tells you specifically, operand should contain 1 column. And so it's telling you exactly what's wrong with that. Now, as I pointed out a minute ago, I could have said, we're looking at the order line. So select order num. That's a valid query. It's going to be useless, but it is valid, right? I will never get a match on that. I'll get an empty set because there's no item num that happens to be the same as an order num. Now, oddly, if our order num convention was similar, where you use 2 letters and 2 numbers, you might get a match, but the data would be bad data, right? It wouldn't mean anything, okay? And that is the case, like for example, all the tables I ever deal with, we use a primary key that's auto-incremented. That's the way I prefer it. And so employee table starts at 1 and just keeps incrementing. Customer table starts at 1 and keeps incrementing. What that means is there is a customer out there who has a customer number that matches the employee number of an employee, right? And so if you try to do something like, you know, where customer num select, you know, employee num or whatever, these are made up fields here, you could get some hits. You'd have some bad data, but you could get some hits, right? Do you understand what I'm saying there? Yeah? Okay.
So you have to always make sure that right here, or where it called, these two are the same.
Yeah, this needs to be, whatever the field is, let me back up here. That field right there should match this. Yeah. Now, we're about to look at what's called a correlated query. Also, depending on who you ask, a correlated versus correlated. So it depends on who you ask. But that query will have a whole different, you actually will be doing one of these numbers in there. Okay, it's a whole different weird animal. We'll look at that in a minute. Okay. So the basic subquery, we feel okay about that?
So the subquery run first?
The subquery will run first, and it'll return a list. In this case, it's 3 item numbers, yeah, and then this will search for those numbers, yeah. So how could I do this as a join instead of a subquery? So we're still going to do select description, right? Well, I won't even need to put item dot description because it's, yeah, there's no other table that has description in it, right? So this part's correct so far, but we need more. What else do I need? If I'm going to join, what table should I be joining in here? Let's look. Yeah, order line. Yeah, because it's saying find the description of each item included on the order number. Well, order number's in 2 places, orders and order line. But order num has no relationship with item. And we're trying to bring order stuff together with item stuff, right? This is item stuff, and this is order stuff. Well, the only place where those two even can coexist is in the order line table. So we're going to need to join order line on order line dot item num equals item dot item num. And that will give us the same exact results. Except we also need to say where order line dot order num, which I don't need to qualify that, I guess, is equal to 51623, right? I don't need to qualify that. I can if I want, but don't need to. There we go. That will give me what I'm looking for. And it's those 3 again, okay? So both syntaxes work, and right now you guys are still kind of early in the stage of how doing these kind of things, but eventually your brain's going to sort of lean towards one way or the other. When I saw this problem for the first time, you know, a few semesters ago when we first switched to this book, the first thing I thought was, oh, subquery. That's immediately where my brain went, was to subquery. Now, your brain may have went right to join, or your brain may have went like, I don't know, right, who knows? That's probably where you're at now because it's so new, right? And don't feel bad. Joins is the hardest part of selects. It's the hardest part of doing this kind of stuff. Okay, any questions so far? Take a look at another one here. Now this one we're going to use a subquery and then a correlated query. The first version here, so we're going to find all the order number and the date for every order that contains item FD11. So let's just look at the tables and kind of dig around, see what we're looking for. And this is, I do this in the real world. I just kind of dig at the tables and say, okay, I want to get a clear picture of what I'm being asked here. So find the order number and date for each order that contains item number FD11. Okay, so select star from orders. That gives me order number date right there, right? But I need to know for each order that contains the item number FD11. So I got to look up in the order line table, right? So let's do order line. And what do we have here? We can tie order number, whatever, to order number and look at the item number. So we're looking for everything that bought an FD11. So there's the FD11, there's an FD11. That's order 51614 and order 51619, and I want to know the date of those. Well, there's the date right there of those two. So I need to bring these two tables together. We're just going to start with a subquery, doing the N like we did a minute ago, all right? So what's that going to look like? Yes, select, that's a good start. Yep. Okay, so select, yeah, the two things we want, right? Order num and order date, right? And it's going to be from the orders table. We don't need to do a join here, orders, where, now this is the part, let's make sure we understand the query, for the number and date for every order that contains item FD11. So what is my subquery going to look like?
Well, so isn't it where item in, and then your subquery would be select item num from,
Order line.
Order num.
Yeah, order num, where order num, right? Because I want to know where the order contains FD11. So I need a query that returns all the order numbers that have an FD11, right? So in other words, we need, so let's back off this part for just a minute. Our subquery is going to look like this. Select order num from order line where item num is FD11. Right? That's the inner query. Because I want a list of all of the orders, like I want a list of all the order stuff that has an FD11. So I think you'd agree that if I run this, it will give me the order number, those two orders. So now I already know the first half of my question, which is what's the order num of the FD11s? Well, it's those two numbers, but I need the date. I can only get that from the orders table, right? So I'm going to simply say select the date and the order num from the orders table where the order num is in that subquery right there. That's it. Semicolon. Nope, semicolon right there. Okay? And that gives me the order date for those two order numbers. Right? Does that make sense? So these can get tricky, right? Sometimes a join's just easier, right? Other times a join's not easier. A subquery is easier. And again, problems like this, my brain tends to go to subquery. Okay? Which one's better? Which one's more efficient? The answer to that question every time in this class will always be, it depends. It will always be, it depends, right? It depends on which DBMS you're using. It depends on how much processing power your server has. It depends on how many licenses you own on the server. It depends on how deep are your queries, how big are your tables. You can have 3 or 4 levels deep of nested subqueries. You can have as many as you want, right? So it depends on a whole bunch of different things. And so the best thing to do, if you're just running a quick query, you got to pick one and run it. I mean, you're not going to really know. But if you're going to save one, which is a very common thing, you'll save a query and you run it over and over again, make different versions, and most database systems have software that lets you test the efficiency of the query. So test the query this way, test it another way, test another way, and see which one comes out the fastest and save that one. You know, so I do that all the time with SQL Server Management Studio. What do you use at your work?
we use MySQL.
Oh, MySQL, okay, great. I've never used any of the MySQL tools.
See, we have Workbench.
Yeah, that's an interface for diving in, yeah. But they do have some testing stuff in Workbench, yeah. So I do use Workbench, but I've never gotten to the testing stuff. And we will be looking at Workbench later on this semester. Okay, next up, let's look at this new version here using the exist keyword, all right? This, again, is a correlated query. And these are actually in your book, by the way. So I stole your book, sorry, but they're in here. So let's take a look at what's going on here. It starts off the same. okay? We're saying select order num and order date, right? And I want to make sure that we're using the one that they like, because this is the idea that the book's getting across here. Yeah. So from the orders table, now here's where the where clause gets wonky. Where the following stuff exists. Okay? So we're going to put something in those parentheses here, all right? Where whatever exists. And at this point, we're going to do a select query, but we're going to be using two different tables here. One table that's in the subquery and one table that's in the outer query. It's a weird thing that you can't normally do. So here's what that looks like. We're going to do a, let's do select star from orders. I never write correlated queries, so I always have to look at the book for this one. From order line and where orders dot order num equals order line dot order num. And item num equals FD11. Let's first take a look at this. Look at this query by itself. Get that semicolon off there. This query by itself. That query will not run by itself. That will give me an error. Do you see why they'll give me an error?
Yeah.
Yeah, I'm saying select from the order line table where something in the orders table exists. So this will give me an error by itself, okay? It's like, I don't know what an orders.order num is because you didn't say anything about that table. Yet, when put all together, this runs just fine. It gives us that data we're looking for. So, let's break this down, okay? What exactly is happening here? So we're selecting the order number and the order date from orders. So let's get the orders thing on here. Select star from orders. And then select star from order line. Okay, so starting here. So it starts off by saying select the order num and the order date. Okay, I got the order num, got the order date, got it. Then it's saying where select everything from the order line table where orders.order num, so where this specific number I'm looking at this very moment. Think of this like a loop, which is this number right here, where that number, 51608, is equal to that same field in a different table, this table, right? So, bam, right off the bat, we have a match where, turn that off again, where this one matches this one. So far, so good. But the next thing it says, and item number is FD11. Well, item number is not FD11. So it moves on, okay? So this did not exist, so it did not pull 51608 and that date, because this didn't exist. All right, it runs again and it checks the next record here, and it looks for a 51 or for a 10 here. Finds a 10, but it's not an FD11. Goes to the next record, finds a 13, finds a 13 here. Oh, let's back up. This one has two 10s. So it finds a 10. Finds a 10, looks for an FD11, no FD11. Finds another 10, looks for an FD11, no FD11. So in other words, this did not exist. This number from orders did not match that number from order line. That did not exist. All right. Next up goes to 13. Looks for 13, there is one, no FD11 though. Goes to the next record, looks for 14. Finds a 14. Oh, and it's an FD11. Grab that record. This existed, so grab it, right? These are complicated types of queries. I don't like them, because I can do the same query with join or with just a regular old subquery. I don't like writing these. I've never used them in the real world, but they're out there. You got to, one day you're going to see one of these, and for a minute you're going to go, what the heck is going on here?
Is this, would you say this is slower? Like it would take more resources to...
It might be a little slower in this scenario because I am selecting all the fields, but you don't even have to select all the fields because all you're doing is saying, does this query return anything, right? And so I could just simply say pick a field out of the order line table, right? Pick quoted price, doesn't matter, right? Quoted price. Because I'm not using the quoted price to compare to anything. I'm just saying grab the quoted price when these conditions are met, right? And so if the quoted price shows up, it'll never be displayed anywhere, but that record will exist, and therefore I should display this stuff up here. That may save a little bit of time, but you see, this can get quickly counterintuitive by looking at it. It's really weird and messy, but that will run too. That'll run just fine. So if your brain likes these, great, do it.
Is it the exists qualifier that allows that to work?
Yeah, the exist qualifier is what makes that work.
I was gonna say, because if it always runs everything inside the parentheses first,
Yeah,
and that won't run on itself, what makes it even
Yeah,
look for it?
so it's a good question. Because normally in a regular subquery, this runs first. Well, this will not, let's turn that back to a star so I don't confuse anybody there. Normally in a subquery, this will run first, right? But in this scenario, that's not what's happening. This scenario, these are related to each other. They are co-related. They're correlated to each other.
So they have to run simultaneously?
Not simultaneously. What it means is grab something from the orders table and then see if something just like that exists in the order line table. That's what's going on there, okay? So grab something from this table, see if that same thing exists in this other table. If it does, then display these things that you grabbed up here. If it doesn't, just move on and check the next record. So if your brain likes these, do it. If your brain doesn't, don't. All right, so how do we feel about these exercises here?
Not exist.
Yeah, you can do not exist. Yeah, you can do that. Where not exists, right? And so now it'll show all the other records. Showed all the records that were not an FD11 or whatever. Yeah, yep. Good question. All right, any others? Okay, have a groovy weekend.